get a switching on off like a digital signal 一种 one 哦。Then what is IC in integration circuit is we use so many device component resistor, capacitor, inductor, or transistor diode integration in chipper. We call this is first IC. And this IC we sync and our integration some device module can get like this Intel microprocess. Okay. Then this is production of silicon wafer. Silicon wafer, and this is silicon material. So we pure the silicon, give this single crystal material, and do the silicon wafer. And this silicon and this IC fabrication, we can do this device. We can do so many application like camera, cell phone, notebook, and some electronic device. This all is done by this IC and semiconductor application. And then we have to start and to do the semiconductor fabrication. If we do this all is done by use paper or lab to do this, we need more cost and time to develop the device. But if we use the semiconductor virtual fabrication, we can reduce our cost and reduce our developer time to do the semiconductor developer and the device developer and something. And before this is some experimental. We use silicon substrate. Silicon substrate to do the thermal oxidation. And why we chose the silicon to do our semiconductor this material, substrate material, because this easy to get the silicon dioxide. And this silicon dioxide is as a good insulator. This semiconductor, this insulator, and another like metal, aluminum or titanium, something to this metal is conductor, semiconductor and insulator. We can to integration to do our device. Okay, so in real, we do the silicon wafer and do use silicon thermal growth. Silicon growth, we use a furnace, so we put the oxygen in. So it's in the reaction. This can get silicon dioxide. And the initial interface here, we grow oxide, release some silicon. So this is in real case. And in our simulation tool, we also can simulate. Before, this is initial. We define initial, like this initial. So use this thermal growth this silicon dioxide can release some silicon. And this silicon is 45%. So you can calculate this is almost 45% silicon to get silicon dioxide. And this.
Okay, so I'm from National Chiang University. So for those who don't know where is it, so it's located in Hsinchu, so about 1 to 2 hours from Taipei. So I'm working there as a researcher as well as a lecturer, and I'm teaching in the Department of Electrical and Computer Engineering. So when I was invited to give a speech in this conference, I'm a little bit confused because it's a little bit general, you know. So then I decided to divide my talk into 2 parts. One part is like the introduction, so I hope most of you will get it, while the second part will touch on my research areas. So if you think you are interested in my research area, then we can discuss after the talk. Okay? So what are that we living today? So this is the world that we're living today, right? It's information age. So as you can see, we are connected. We are connected from all over the world. The connections is due to the internet, right? So you might wonder what kind of the things that actually transmit between one another is the information. And you might wonder how come this connection boils down to a representation called bit 1010. So how can we really describe the information in terms of the bits? And what is the challenge in order to send this bit from one part to another part? Because that's the thing that actually we experience in our everyday life. Okay. So some examples that may contain some information. Some of you might think about these questions, right? So the first question is, will you marry me? So obviously there are 2 possible answers, yes or no, right? Second example, suppose I'm nice and I try to give a present to one of you here. Obviously, all of you will be excited, right? Because you know that I will give a present, but you don't know to whom. The third examples will be a little bit more specific. So I will give a present only to audience sitting in the front row. So obviously there are only 2 persons here. So all of you that sit at the back will not be excited because okay, you do not belong to the third person, right? So the number of the answer is getting smaller. So this all the thing characterize what is information. And as you can see that as we have more and more answers, the information content becomes larger, right? Because more people will be interested to find out about the answer. So the number of the possible answers shall be linked to information. Okay, to be more specific, so let's have more detailed characterizations for the answers. So suppose that we use the first question, and the question is, will you marry me? Of course, if the girl has something, it's already engaged. The answer no, it's more likely, right? The answer yes, it's less likely. But if yes is true, then we will be excited, right? Because it's less likely, you do not expect it. You will be excited. So obviously this yes actually contains more information. Less likely contains more information. Another questions like, will an earthquake occur in Java in 5 minutes time? Obviously, it's more likely. There's a higher chance, right, from the experience. And yes, obviously, it's less likely. But if the earthquake will happen in Java in 5 minutes time, we'll be shocked, right? And the news keep coming from the news stations, right? Probably in 3 days we will still hear the same news. So this answer, since it's less likely, we do not expect that to occur, will be shocked and contains more information. So the information does not only depend on the number of the possible answers, but also depends on the probability of the answer. Okay? Hope that's clear. And indeed, the information is the relation of the uncertainty. So this credits to the Claude and Shannon. So he was writing a paper on information theory, and we, in the research community of the information theory, always regard him as the father of the information theory. Okay, next. So then we can represent what we have as yes and no as the information, right? Yes and no can be represented in terms of the binary digits. For example, you can assign 1 as yes, 0 as no. And you can also switch. It doesn't matter, as long as you are consistent. Okay. So in general, what we can do is, for any event or for any answer that have the probability pi, in this case, has the information of log 2 1/n. Okay. So the principle is the more likely the events, the fewer bits needs to represent the information. So it's more likely. So you already expect that to occur. But if the events are less likely, obviously we need more bits to represent information. So then you can do some averaging, and this average called entropy. For those who are not familiar with it, don't worry too much, just get the idea of representing the information. Okay, so let's have a look on the example. So we have the two possible answers, yes and no. We can assign bit 1 and bit 0. You can exchange, doesn't matter. So the answers actually can be represented as a symbol. Depending on the number of the answers, you might have a different number of the symbols. And for example, if you have 4 possible answers, you can represent with the symbols A, B, C, D, or any other symbol, as you wish. It doesn't matter. This symbol, it doesn't matter. Then you can assign the symbols with, the information. So these 4 possible answers have 2-bit information, so that you can assign 0, 0, 0, 1, 1, 0, 1, 1. So just all possible combinations of 0 and 1. So the question is now is getting interesting. What happens if we have 3 possible answers and with non-equal probability? So this all assumes that your answers are equally probable. What happens? So we have a constraint, right? So the constraint is the number of bits has to be non-negative. Okay. So you cannot have number of bits to be -1. It's not realistic. In the hard disk. So in the hard disk, you might not realize that actually we have the information transmission here. So we write into the hard disk, so the hard disk will serve as the medium, and when we read back from the hard disk, it means that the medium forward the bits to the intended recipient. So there is a communication process, but it's not real time. Another example that you might not realize is the neural systems. Okay? So actually when, people slap onto your face, for example, you feel it hurt, right? Because there is some message is transmitted from the skin to the brain, so that the brain can tell whether it's hurting or not. So there is a process of the information transmission in the neural cells. So another example is a bacterial cell-to-cell communications. And when the bacteria infects our human body, it actually forms a colony first. So it first communicates with the surrounding to find out whether you have friends or not. Once you find a friend, then the friends will get closer and closer to you. You form a colony, and once the colony exceeds a certain threshold, it will, emit a certain chemical substance that basically infects your human immune system. So that's the way bacteria communicate one another. And then the thing is, the challenge is in the medical world. Obviously, I'm not doing that, but the challenge is it's not only to develop a medicine that kills the bacteria, but it's to disrupt the communications among all the bacteria. Okay? So let's say you disrupt the communication, then obviously they will not form a colony, and then you will not suffer from illness. Okay? So that's for the introduction. So let's have a look at the more complicated thing. So basically, this is the representation of all the communications that we have been talking. So here we have a set of the messages. So the set of the messages can be the number of the answers that we have. So I just assume that there are k. So I index from M1 to Mk. And then you select one of them. Okay. You transmit over the channels. Then before you transmit, you do coding. So coding is like assigning the bits. So you have seen I described something on the bit assignment. So that is one of the example of coding. Okay. So it's not coding in computer like you try C++ or anything like that. So then this channel will basically output some things which might not necessarily be equal to the things in the input. And then we have the decoding, which basically try to guess what message that was transmitted before. So obviously this basically has the error probability as the probability that your decoding output is not equal to the message that you just transmitted. Okay? Alright, so in the ideal channel, so if your channel is ideal, so the output will always be the same as the input. You always
for the military services. Currently, why I wear this custom? Because I'm one of the coordinator of the consortium in Indonesia to coordinate all the researchers, all the company, all the institution in Indonesia who work together in military services for the warship. That's why we have some organizations, some NGO organizations for the first 3 years. And start from this, we try to legalize this organization called KPKPN, Consortium Pengembangan Kepala Nasional. It means National Consortium for Research and Development of Warship. It's not only surface warship, but also underwater warship. It's called submarine. Also the rudal. In Indonesia, it's rudal. In English, it's a rocket. It's also developed some unmanned vehicle for aerial surveillance applications as a quadcopter and many other applications. So in this opportunity, I will try to tell you globally, not focus, not in detail, but only globally. Okay, so this is the list of others. Okay. In this opportunity, I will not to talk much about the basic things, about the sensors, the instrumentations, the algorithms, how to develop a control system for any application of control, such as the autopilot control, balancing control, motion control, stability control, communication control, or any kind of controls. I try to deliver you, to guide you to the gate, what we doing now in this consortium. The first background is the basic need of the country to maintain of the nation. So it is called a proud of nations. The nationalization is the keyword for every citizenship to be proud. Let's frankly say that I'm proud to be an Indonesian. I'm proud to be a Taiwanese. I'm proud to be an Indian, maybe. But nowadays, we can say that I'm proud to be in the world citizenship, right? Because we are connected each other from one country to another country easily using the broadband services, internet services, Line, Facebook, Twitter, anything else. But there is some sensitive cases that we cannot avoid it, that everybody would like to show, everybody that would like to I don't know how to say that, everybody would like to expose their majority, their power to others, to show that they're more than others. In special cases, not everything, right? And we know that, just for example, every researcher, professor, okay. Everybody want to tell you, to show you that there is one capability, there is one expertise that everybody have, others that is different than others, correct? That is the way how to maintain the nation, the unity of the nation is how. Let's say a simple. If Taiwan or India, they have some special task forces, some undetectable task forces, unmeasurable war vehicles, so they will feel more secure. They will feel more safety than other countries, such as Taiwan. Maybe they will feel suffer from the intimidation of other countries, from China, maybe, from Japan, maybe, we don't know. For India, maybe they suffer the intimidation from close neighbor countries, Bangladesh, Pakistan, that we know every day there is a war everywhere around the area, also in eastern area. Also in Indonesia itself, we have a standardization how to protect our nation from the intimidation from neighbor countries, Singapore, Malaysia, Australia, Vietnam, Philippines, Thailand, more countries around Indonesia. That's why we need to set up, we need to build our standardization. How powerful are we to defend, not to attack? Once more, to defend, not to attack, because if they try to interrupt, they try to attack us, we don't have to be afraid. We don't have to be worried. How can we defend from external attack? This is the basic need of the country to maintain the nation. How to set up the standardization, how powerful we are to defend ourselves, especially from attack, from the intimidation. It's not only the communication intervention, it's not only the physical intervention, but everything that could take us to the danger. We need to determine, we need to clarify, and we need to make standardization how to defend from that kind of intimidation. So there are many kinds of warfare. In the military, we will know many definitions kind of warfare. It is AAW, it is air-to-air warfare. ASW, air-to-surface warfare, or ASUW, air-to-submarine or underwater warfare. But in principally, we may classify into four kinds of warfare technically, principally and technically, not military, but technically principally. This is air or space warfare, using some spacecraft or some airplane or satellite or many kind of flying objects. And then ground warfare, oceanic warfare, divided into two classifications: surface warfare and the underwater warfare. And also electronic warfare, some communication information technology. They try to develop some radar, some sonar, and also the jammer, and some material people, some scientists in area of material, they try to develop some radar absorber material, which could be also done by two approaches: passive radar absorber, also active radar absorber, which means that active radar absorber, they try to adjust the communication, the frequency, the transmitted frequency from the transmitted in the vehicle. They try to jam it, and they try to absorb it. The second method, we call it the passive approach, or passive method. We try to develop some material that may absorb the frequency which is transmitted from the ground station, from any vehicles around the locations. And also non-technical intervention, we may not discuss about non-technical intervention because this this depends on the political interest. It depends on the bargaining positions of the country in area, or how to convince the enemy, how to convince the colony, how to convince the whole nations. This is only the non-technical intervention. And the requirements for the warship, for example, we try to divide it into three classifications. Only 10 minutes, I don't know how to operate. The platform, it means the vehicle. In platform, we may talk many subjects about the naval warships. So principally, we may divide it into two classifications. The first will be the naval architecture. Naval architecture will talk about how to design the build, the geometrical shape, the functional shape, anything related to the mechanical area. For example, in this platform, we will talk about the stealth technology. Stealth technology means, in bahasa Indonesia, is called siluman. Stealth technology in English called undetectable, unusable, unidentifiable, which related to we don't know that there is a spy around us, there is a weapon around us which always ready for 24 hours, 7 days a week, 12 months a year, ready around us, ready to spy us, ready to kick us, ready to attack us. This is a stealth technology that we try to develop. And the second classification is supposed to be the IWS. IWS means integrated weapon system, and also combat management systems, which is more likely to semiconductor technology, maybe. And also
for this electromagnetic interferential link made of polymer and ceramic Fa3O4. So it's like it's a ceramic and oxide of iron. This is actually a ferrofluid. Before I start, does anyone know what a ferrofluid is? So you may think a ferrofluid is like a milk, a colloid, but the milk is a liquid which contains finely dispersed fat particle, and for this ferrofluid, ferrofluid is like a liquid which contains finely dispersed ferromagnetic particles, which in size of nanometers. And so this is not an empirical experiment. This is like a references study. So let's start. Why composite of polymer and ferrofluid for electromagnetic interference shielding? Because nowadays the materials used for electromagnetic and interference shielding are mostly metals, and metals, as we know, metals are heavy. So from this chart, we can see that the increasing demand on silver wafer leads to increasing demand on electronic devices, and the electronic devices that we use, they contain electromagnetic interference shielding, because if they don't, for example, in your cell phone, so you may hear like this sound because as a result of the electromagnetic interference. And many years ago, and it may happen in your television when you change a television to channel 8, and you started to see pictures from the other channel. So that is electromagnetic interference. So from this chart, we can see that the increasing demand on electronic devices must lead to the increasing demand of electromagnetic interference shielding. So we need to develop a material that is lightweight but still have a high ability to absorb the electromagnetic wave, so it does not interfere with the device itself. And the analysis of the electromagnetic wave. So we can see that the electromagnetic wave itself is a combination of oscillating electric field and magnetic field. The Faraday's law states that when an electric current flows, it results a magnetic field, and when the electric current itself varies in time, it results in a varying magnetic field. I'm sorry, it should be magnetic field. And when the electric current itself oscillates, it results in oscillating magnetic field. And this oscillation, it can propagate through the space, resulting in electromagnetic wave. So this is like the radio wave and light that we see today. And the electromagnetic interference itself, electronic devices use electromagnetic wave, and the other devices also emit and absorb electromagnetic wave. So for example, like when we have a radio and we decide to change the radio to frequency, for example, like frequency A, and the other devices also emit electromagnetic wave from, like, for example, like frequency B, and it interfere with the electromagnetic wave that our radio emit or absorb. So it's analogous to water ripple that you see when you touch your finger on water, and you touch your finger to another part of the water, and it starts to interfere. Yeah, that's that's analog to this case of electromagnetic wave interference. So how the electromagnetic interference shielding works? So the electromagnetic wave interfere with the other electromagnetic wave that the other electronic devices emit or absorb. So the way we protect our device from interfering with other electromagnetic wave is to establish a shield or a cover to isolate our electronic device, so it does not interfere with the other electromagnetic wave from the outside. And how it works, because electromagnetic wave consists of electric field and magnetic field, so the electromagnetic interference shielding should absorb all the electric field and the magnetic field. So it's like it nullifies all the electric field and magnetic field. So the material itself for the EMI or electromagnetic interference shielding should have a high electric conductivity and ferromagnetism. So when it is exposed to electromagnetic wave, it nullifies all the electric field and magnetic field. So this is our design to a new material, which is a composite of polymer and ferrofluid. As I stated before, the material for electromagnetic interference shielding should have high electrical conductivity and high ferromagnetism property. So we decided to use polymer because a polymer is lightweight. So we tried to find what polymer that has a high electrical conductivity or with also a high ferromagnetism property. So the polymer that we found on references is polyaniline. Polyaniline is actually like a white fiber that has electrical conductivity property as high as most metals. So we try to combine this polymer material with other material that has a high ferromagnetism properties, which is the ferrofluid itself. So the ferrofluid, as I stated before, is like a colloid which consists of finely dispersed ferromagnetic properties, and with ferrofluid nanoparticle which has high ferromagnetism properties. So we expect this material to have a good ability to absorb electromagnetic waves. So it protects a device from electromagnetic interference. So how do we manufacture this material? First, we manufacture the polymer first. So it's from the previous slide, we can see that this funny polyaniline nanoparticle is dispersed in the matrix. So it's like a major material which consists of these finely dispersed particles. So the matrix itself, or the material which contains all the nanoparticles, is polyvinyl alcohol, which is actually the material that you use for wiping your car. It's called kanebo here. So how do we manufacture this polyaniline and polyvinyl alcohol? Is first we use a polyvinyl alcohol solution. So we dissolve polyvinyl alcohol particles in water and heat it up to 90 degrees Celsius and stir it for around 3 hours. So let it all the polyvinyl alcohol particles dissolve, and then we add the polyaniline salt. That I'm sorry. This is the polyaniline salt, and we put it into the polyvinyl alcohol solution and let it dry at room temperature. So what we have is a solution containing polyvinyl alcohol and polyaniline, and we cast it. What I mean with cast is like we pour the liquid solution into a mold, thin plate, and let it dry so it forms like a thin plate, a thin plate, which consists of finely dispersed polyaniline nanoparticles. After we have the plates, we cut the plates and combine it with the ferrofluid. So how do we make these ferrofluid particles? Is we combine all these ingredients, which is used to this is actually an adjunct to corrode metal. So it forms like whiting. It's used to corrode metals. We combine these ingredients with ammonia, so it creates precipitates of these ferromagnetic particles. But these ferromagnetic particles cannot dissolve in water and cannot dissolve in other solvents, so we need to add something to stabilize these particles so it can dissolve or it can form a colloid in the liquid carrier. So the ingredient that we add to stabilize this particle so it can form a colloid is oleic acid. It's like an acid that we find in most oils nowadays. So we add this oleic acid to these ferromagnetic particles, and it forms a colloid. So this oleic acid stabilizes this nano ferromagnetic particle, so it forms a colloid. So it can now finally disperse in the liquid carrier. This reaction, it forms the nano ferromagnetic particles. After we have the polyvinyl alcohol and polyaniline polymer, we combine it with the ferrofluid. I'm sorry, it's jammed. We combine it with the ferrofluid nanoparticles with a radiation doping, so it can mixes well with the polymer. And how do we know that this material is good for absorbing electromagnetic wave? Is that we characterize it with this way. So in metallurgical and materials engineering, we have standards for testing materials, and we use this standard, American Standard for Testing Materials specification, as you can read here. We expose the material to radiation, to a radio wave radiation, and we measure how much energy is absorbed by the material, so we can see how good it is on absorbing the electromagnetic wave. And we also characterize the electric conductivity of the material, so we can also see the electrical properties of the material. From our references study, we can conclude that the composite of polyaniline, which has high electrical conductivity, with ferrofluid, which has high ferromagnetism properties, the composite will show increasing absorbance of radio wave and other electromagnetic wave with increasing ferrofluid addition. So when we add the ferrofluid particles more and more, we expect the material to absorb more and more electromagnetic wave, as you can see here. And it is as a consequence of increasing conductivity from the polyaniline nanoparticles and the increasing ferromagnetism properties resulted by the ferromagnetic particles.
From droplets, it just sprayed away in the glass, and if we apply the titanium dioxide film onto the glass, it's just the same. It's more hydrophilic. But then if we apply one layer of hybrid film, just one layer, it becomes more spheric, and after that, in 3 layers, it becomes full of spherical. And quantitatively, we can see the CA from this data. It is seen that the hydrophobicity was increased with the increase of composition and layer. And we can see the highest CA here is more than 150 degrees. So this highest composition has the superhydrophobic property. And also that if we see the picture in the center, this is the same picture, and this is the same glass, but we tilted the glass, and after we tilt the glass, the water droplet doesn't slide. It means that there are strong interaction between the water and the glass surface, and it doesn't mean that the glass doesn't have self-cleaning property. So I would like you to show this scratch resistance first. The scratch resistance. Generally, the scratch resistance were increased by the film composition and layer, but the highest one is decreased. It is normal, so you can see that the film has passed its optimum composition to achieve this scratch resistance property. And yeah, I would like to send you a video. This is about the self-cleaning test. We just spray water in the glass. There are three kind of glass. This is the normal glass. If we put the water, the glass will stick on the glass. The water will stick on the glass, doesn't run off. This is the hydrophobic one. It's transparent and the water doesn't stick anymore. We can see it runs really smooth. And the second one is the super hydrophobic glass. It is not transparent, but the water shape is more spherical and it really run off the glass so smoothly. This is the proof. We can prove by this video that all of the hybrid film glass has the self-cleaning property. And since the chemical nature of all the hybrid film was the same, so it was proposed that this self-cleaning phenomenon was the responsibility of the surface runners, as we can see in this IFM image. You can see in this IFM image, this is the surface of water film. So if we see manually the glass, it is flat, but if we see through the instrument, it is very rough. So with the increase of the composition, the surface roughness is increased. It's really rough. In this micro and nanoscale roughness, we can see the hydrophobic increasement in this glass. And after that, we can see the transparency here. We compare it by this writing paper. Generally, the transparency it's more depend on the coding frequency rather than the composition. So it's the same. And we can see from this UV spectra is the same layer has a similar transparency. And we can see the more layer we put into the glass, we will get a lower transparencies. And since this layer was transparent, it is proposed that to achieve the transparent hydrophobic film, the thickness of the film should be less than 100 nanometers to achieve this kind of transparent film rather than this rather opaque. And the film stability, we put the film into two kind of condition: the humid environment one with relative humidity more than 90%, and you can see that for 4 weeks exposure, the film was very stable. There's no decrease, just little decrease, but if we put it in outdoor environment during the summer, in Indonesia, summer, we have just a little rain, or there's no rain anymore, and we can see the decrease, but it's not so low. We can see that it's still hydrophobic one, but so it doesn't affect so much. And we can see this film was sufficiently stable. Okay, now the conclusion. There are maybe 5 lines of, we can conclude the microstructure of superhydrophobic film can be obtained by incorporating the nanoparticle of titanium dioxide and the dosilamine, where the maximum Ca is 155.5 degrees, and the one who responsible for this phenomenon was the combined effect of the surface rudeness and the formation of original hybrid film, which the hydrophobic core was directed into the external surface. And the third is nanoscale thickness is really required to get a high transparency film, and the resultant film you can see it is sufficiently stable. And I believe that this work can provide the new development to create the transparent and super hydrophobic based on the hybrid material films. Okay, then this is some acknowledgement and some references. And if please don't be hesitate to let me know if there is some suggestion or advice for the development of this product.
Hi everybody. First, I'm from the Southern Taiwan University. Today we will present about the my paper. The title of paper home last is home application they use in the Microsoft Kinect. My name is Nguyễn Văn Vĩnh. I'm from Vietnam. Okay, in this is the content of the paper. In this content, I will present some of the topic and following the first abstract, the second in introduction, the third OpenAI and NIT drivers, the fourth system design, fifth and in finally the conclusion and future work. This is abstract. The goals of this research present an application with you the Kinect camera to control some device by nature. In this application, I use the Kinect camera, IR transistor sensor, microcontroller, and personal computer for this application. The Kinect will recognize some hand gesture from the user. After that, the information gesture will communicated with the microcontroller by RS through 3 cable so that it can send the signal to the control some device via IR sensor. The IR sensor already connected the microcontroller by the Bluetooth pin. You can see this is the figure for the Kinect camera. you can see the Kinect camera in some device for the game for the eSport. The Kinect is a depth camera by Microsoft for the eSport 330 game based around the webcam style as on the peripheral for the eSport 300 stick control. It enables user to control the interact with the eSport 300 without the need to talk the game controller through a natural user interface using the gesture and spoke command. It is OpenAI. If you have time to research about this device, you can have many the framework. It is a framework for the Kinect driver. You can but in this application, I only use the OpenAI and AIT for the driver. I only introduce this. You know the OpenAI, that means the open natural interaction. This is an organization that offers the natural interaction device for the use across multi-tool. The natural interaction device allows the more user-friendly experience in which the player can communicate interaction and whisper emotion and voice command and something like this. This is a system of design. You can see this is the user interface of the Microsoft Kinect. The user will implement some gesture to the Kinect detect your gesture in this application that you gesture is a hand gesture and the distance from the user to the Kinect at least 50 centimeter and then the Kinect will connect with the PC via USB cable and then the PC connected to the microcontroller via AISCT protocol and then send the microcontroller will connect it with the AI sensor and AI sensor is the same the remote control to control your TV or something device controlled by the IS protocol. This is implement in the remote control for the TV. You have many the function. In this day, I choose some the function in the TV như channel up, channel down, volume down, and this is a gesture. You can define your gesture right sweep, left sweep, positive cycle detector and negative cycle detector to control your device. This is some figure in my application. In this application, I use the sweep. This is sweep left to the. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Today is actually this is kind of my first experience about giving presentation, not official presentation like this seminar conference. But here we would like to introduce some AI algorithm here that we were using is neural network. So firstly, neural network is kind of how human brain thinking there. How do we know who are you, what's your name? By learning. Actually, the learning of the model is the same how human do learning here. And here we try to develop some very small modification algorithm here. We just use self-adaptive. And this was applied to the brain-based function level. Actually, the brain-based function level is when someone have the irreversible apneic coma. Maybe we can show next one. This is only an acknowledged one. And this is like the previous about the outline. And this one.
like when someone has reversible of the brain function, they still be able to characterize for the normal coma. But when someone has the irreversible, here they not easily change to the reversible coma. This function, this level of the how small or big the function, brain function died here. That's according to the brainless level. This is according of the Van Norman. And why we should make this? Actually and frankly to say, this is first how some doctors decide for the organ transplant. And the faster the doctors decide this patient was or work belongs to the brain death, the organ transplant protocol can be done afterward. And in the deciding this patient belongs to which level, they need some like economics, materials, human resource, yeah, for detecting this kind. And actually for detecting this level of the patient which has the different level, at least 2 doctors, and they need 72 hours for decide this level. And here, especially in Taiwan, this data was taken from the National Taiwan University Hospital, and not all the brain death patient, the family wants to give the further action for the organ transplant. And here's the neural network want to make sure. Actually, this model cannot substitute the doctor's position, but we help the doctor to decide faster and for the more fresh organ. And what input we need here to the model? Actually, the neural network is like the input and output. This should be the output modeling. Here we need the heart rate, respiration rate, pulse, blood pressure. This is SpO2 we said, and such kind of the medical term that actually I didn't really understand because I was in mechanical engineering. And here is the brainless level as the output. The data that we have had here is not so many patients. We only have 7 patients here with the totally 316 data set. For the neural network, they use 6 patients for training and validation.
I think the difference only one letter, L and D. Yeah. But I think it is almost the same about its meaning. Yeah. We think it's very human being, and welding is very metal. Yeah, metal. And now I will share about the dissimilar metal between aluminum and steel. Okay. Okay. The outline of my presentation is one introduction, and the second is experimental procedure, and the result and discussion, and the final is conclusion. Okay. In introduction, I will say that the application of dissimilar metal is very broad because today the lightweight vehicle to reduce the fuel consumption is future oriented, and there are a lot of light material, for example aluminum or Dr. Nurhadi said that he used the composite material, and but the burning, the rate of burning of composite is very high, so it can burn easily. But in this case, we will use P-metal material in one construction, steel and aluminum. Aluminum is light material, but its strength and its thickness is very low, and I combine between steel and aluminum. And it is not difficult. It is very difficult to join steel and aluminum. Maybe I will give you example like wedding. If you don't work with someone, then your parent will marry you with someone that you don't love. I think it is very difficult to join. I think it is like it is the same case. Yeah. Steel and aluminum is have different properties, different material, and they have different properties like physical, mechanical, and metallurgical. And there is a little solubility in aluminum in steel. Okay. So it is very difficult to join aluminum and steel. But because there are demand in dissimilar metal, and because it's more economical, then if we use all of construction using the aluminum. Because of the difficult, so in this present I will propose how to make aluminum and steel bond. And how about the physical properties of bonding, and how about the mechanical properties of bonding? And so the aim of this paper is to investigate the mechanical and physical properties of spot weld of dissimilar metal due to filler thickness. I propose steel and aluminum can join by using a filler. A filler is too close. Yeah, the function of filler is too close the different properties. Okay, the material and welding processes is like this. The chemical composition of steel SS400, carbon content is 0.054, and the chemical composition of aluminum, because this one is 5 series, so the main alloy is magnesium. Sorry, the main alloy is magnesium. And the spot welding, we use the constant parameters. Weld current is 7 kiloampere, and the weld time is 20 cycles, and the electrode force is 6 kilonewton. And the joint, we can see the joint, steel is upper side and the aluminum is lower side, and we use a filler inserted between aluminum and steel. Filler is a mixture of 50% aluminum and 50% steel powder, and press to join them in the mold to form a ring with the diameter 10 millimeters. Okay, the joint like this, and spot weld like this. Okay. And And joint characterization, we use UTM, universal testing machine, to know about mechanical properties and microviscous hardness, to know the hardness of well, and to know about macros and macrostrata, we use optical microscope. Okay, the result is we can see if we use
Omega 8 microcontroller. First of all, I would like to introduce myself. My name is Siti Indriati and my partner is Widodo. We are from State University of Yogyakarta, Indonesia. Well, we divided our talks today into 8 parts. The first is background, and then the second is purposes, the third program implementation, the fourth basis of the program implementation, and then the next the implementation techniques, and then automatic oyster mushroom watering system design, and then result analysis conclusion. Well, let's start from the first point about the background. Well, Indonesia is a country which is located in tropical area. It makes this country has many biodiversity compared to the country which are located in subtropical area. The biodiversity can be seen from the ecosystem that exists in Indonesia, such as forest ecosystem and then rainforest ecosystem, mangrove ecosystem, and many others. Well, one of the biodiversity is a mushroom. Do you know mushroom, right? Uh, well, in Indonesia recently there are a lot of cultivators who cultivate mushrooms, especially in Bantul, Yogyakarta. The reasons why the farmers are interested in cultivating mushrooms because of the nutrients of the oyster mushrooms and the potential of the oyster mushrooms which could grow all along the year. However, during this time the watering system is done manually, so the farmers should water the oyster mushrooms manually, and then the temperature observation is not practical. Next. And then mushroom will be damaged if the temperature is not appropriate. And next. And the market demand continues to rise from time to time. Well, next. So we create an automatic oyster mushroom watering system design using temperature sensor based on Omega 8 microcontroller. Well, the purposes of this research is to increase the quality production of oyster mushrooms, and then increasing the quantity production of oyster mushrooms, and then the last is applying the watering system continuously. Well, program implementations, the first is time and places. This program started from January 2012 and up to June 2012 in Bergan Wijirejo Pandang.